At the end of today's work, I am just assessing the work done. So many capacitors have been soldered. All these are 100 nanofarad capacitors. This is a preset that is for adjustment of the balanced modulator. Then we have the electrolytic capacitors. There are only few. Then there are mylar capacitors. This is a high voltage, 100 volts capacitor. And there are a few more mylar capacitors which will not be very differently seen. This one is blue, so it's easy to see. So I was assessing the work and found that 29 is not enough. So many are there. All these shapes, these oval shapes you can see here, are capacitors to be fixed again. See, and leave alone the number of resistors which are remaining and the coils. I have to fix Toco coils, then I have to wind the toroids. All those are pending work. Transistors have been fixed, all the transistors, a few diodes, relays and connectors, everything has been fixed. So there are a total of 5300 nanofarad capacitors on this board. I have just finished 29. That means 24 to go, and after that the resistors and toroids, filters, everything. At 7 megahertz, that is a 40 meter band, the capacitive reactance of 100 nanofarad capacitor is roughly 0.23 ohms. They are tiny, cheap, and effective across HF spectrum. An important point to be noted is that when soldering these, keep the leads as short as possible. Long leads act as inductors at high frequencies, which can cancel out the capacitance and turn your bypass into a tuned circuit that causes the very oscillations you are trying to prevent. Why are there so many 100 nanofarad capacitors in BITX? There are several reasons. Every active stage, like the bidirectional amplifiers or the VFO, draws current. When a transistor switches or amplifies a signal, it creates tiny, rapid fluctuations in the voltage rail. Without capacitors, these fluctuations travel along the power lines to other stages, causing unwanted feedback oscillations or motorboating sounds. A 100 nanofarad capacitor placed physically close to the collector or drain of a transistor acts as a tiny local reservoir. It supplies that instant demand for currents and shorts any high frequency noise on the DC line directly to ground. In many parts of the BITX, you want a component like a resistor to provide DC stability, but you don't want it to affect the RF signal. By placing a 100 nanofarad capacitor in parallel with an emitter resistor, you allow the RF signal to bypass the resistor and go straight to the ground, because a capacitor's reactance is very low at RF frequencies. This significantly increases the AC gain of the amplifier stage without ruining the DC bias. Because the BITX uses multiple stages of amplification, you often need to pass the radio frequency signal from one transistor to the next while blocking the DC voltage. A 100 nanofarad capacitor is large enough that it looks like a short circuit for your 7 MHz or 14 MHz signals, but a broken wire to the DC supply. This prevents the DC voltage of one stage from messing up the bias of the next.